Hi, and welcome to this month's webinar, which is hot, hot, hot. We're going to talk about unit testing today and AI. I think this is the fifth already that I'm doing, the webinar that I'm doing about doing things with AI. And this is going to be a bit different because this is more unit testing focused. And I think the first one that I did was with TDD, and you can check out the recordings on the YouTube channel. But all the others they did were mostly testing related or QA related. So this is going to be a bit different. We're going to talk about unit tests. We're going to talk also about component tests, and because I consider them honorary members of the unit testing world. Other than that, enjoy, grab a cup of coffee, don't step on any Lego bricks while we're doing this. My name is Gil. I'm from Testing Gil. I'm a trainer and I'm a consultant, and I work with different people who do different things on software projects, sometimes even hardware projects. And I help them with unit testing and clean code and testing and automation and everything about making software better. If you want to ping me, this is one of the ways. Other than that, there's the blog, there's the YouTube channel where videos come up almost every week, including this webinar series. So you can catch up on this at your leisure. Let's start. Before we start, like I said, I'm a trainer, and therefore I train people. And during the last year and going forward, a lot of these AI stuff and topics are going to go into the courses that I teach, including unit testing and TDD, things that we're going to do today. Can't ignore the future, can't we? So again, if you're interested in some kind of training on things that still matter, like unit tests, let me know and help. Okay, so what we're going to talk about today is stuff that we can do with AI. It's always better to remember what's our goal. And if you watch the other webinars, it always starts with coverage, which is kind of a bad word. Coverage means that it's not line coverage, it's not case coverage out of 100%. So it's not like we're running after a number. What we're actually after is more confidence, especially when we're doing unit testing. It's not like we're checking our code, we are, but basically what we're trying to do is gain some confidence that if we give this code to somebody else, could be somebody on the team, could be on the testing team later, could be the customer at the end, this code will work. So it's not really coverage that we're after. It's like gaining the confidence that this thing won't break somebody else's code. And if I touch this bit of code, I'll know about it sooner rather than later. So that's the basic of unit testing. And we want to continue that. But something's different a bit about unit tests and component tests. Like I said, we're going to talk about this today as well, than regular system testing or API tests. And that is something about flow, which I can't really define, but everybody's written unit tests know about this. So we have a kind of cycle, right? We write code, we write tests, depending on your own personal flow. I like TDD, so write tests first, but it doesn't really matter. There's some kind of flow going on. And like we write a bit of code, we test it, we see, we get the feedback that it actually works, and we move forward. And this doesn't happen in system tests or API tests. There's no like going into this pool, doing something, and then going to this pool, doing something, and continuing working together. So this kind of flow, dependent, like people optimize it and kind of get a feeling of this is working for me or this is not working for me. They do that and they feel it. And one of the things that we don't want to lose is this kind of feeling. Like if we're in the flow, we can move productively forward. And we kind of look at AI as something that will like jump us forward. But you'll see, and if you try to generate a couple of tests, you already felt that like it doesn't feel like that. It felt, at least for me, when I'm doing that, like on real project, like I'm generating stuff, regardless what it is, I stop. I review, I look at everything that it created. I need to approve that. I don't like that. This creates a different rhythm of development that I'm used to. And I'd like, at least as part of my goal, to at least keep that flow, or at least keep something in terms of the feeling that I have as I'm working forward, to have this kind of flow. So enough about flow. We want that. Obviously, we want more feedback. Obviously, we write automated tests to give us feedback that this is still working, this has stopped working. And one of the things that we're going to talk about, obviously, is if we want more coverage or more confidence or more, we probably want more tests and more help. from the genie in charge. So obviously we want all these things when we're talking about incorporating AI into our unit testing. So unit tests check small pieces of code. I'm not going to go into what kind of piece is that. It could be a piece of paper. No, but it could be a function, a class, a module, whatever you want. We can discuss what the real definition is. It doesn't really matter. What I usually think about is the feedback cycle. But one of the things that we try to do in order to have this flow going is two things really. Have it run quickly, obviously, and we try to limit dependencies. One of the things that is really important for us for this confidence is that we control as much as we can. So if you take mocking into consideration in regular unit tests, this is a way to control what I'm testing. Like if this returns 3, I know my code will react to this 3 in the way that I specified. So I want that. And this is why I'm kind of pulling component tests into this conversation. So what are component tests? So up until like 15 years ago, maybe less, component was something that is bigger than a class, talking about systems. But then frontend came and React came and Angular followed in Vue today. And the front-end world created components and like took over the name. So now you have component tests, and it's not that you didn't have those before, only they were less defined. If you say component test to front-end developer, they'll know what you're talking about. Now, mostly front-end tests are quicker than pulling up a full browser, loading a page, and stuff like that. And the components are like reusable component. You're supposed to test them the way you're thinking about a function or a class, because what you're kind of defining is that this piece of code, it's bigger than a function or a class, should work regardless of its container, same as a unit, like a function or a class. It could be that it has some kind of dependencies, like calling outside the component, which might get me worked out around, is this a good design or not? Let's not talk about this, but it can be. And then I want to control comes out, what comes back in through this API call, because again, I want to make sure that my code works as I want it. So component tests, especially front-end tests, are slower than regular unit tests, mostly, but they still don't require whatever we need for API tests, like running pull server or a browser. If you're talking about front end, like picking up a whole browser, loading it up, loading the entire page, and testing it with all kinds of other dependencies. So component tests are part of the discussion today. In order to do this, and you'll see with examples I'm going to show you soon, and this is something that I've kind of experienced through all my AI adventures. If you want to have this kind of flow that we talked about, if you want to have control, if you have the feeling of control of what you're doing, you need to split things into small things. So I'll show you what I generated in 3 prompts, really, but this was like a big thing. And then you say, well, that's a lot of code generated. It could be like for tests, it could be like test ideas, it could be a lot of things. But in order to not get stuck into, okay, now I need like 2 hours to review everything it generated for me, I need to limit things into small things. Sometimes you might want to jump and do something bigger, but you'll pay for that in sort of validating and reviewing stuff. The one thing that is different from regular testing most of the time with unit test and component test is that our AI companions, copilots, co-genies, have access to the code. And, you can like ask Copilot to like generate unit test. And you could do this with Visual Studio since 2005. And there were not great tests either, but there is some context that is available to the agents running inside the IDE, which gives us a lot of options, more options than we had before. And that's sort of like going into white box versus black box testing, but it's going to have an effect because we can use that, at least in terms of the actions that we're going to do, but also realizing that if the context is there and available, probably, not 100%, but probably the results will have some better purpose for what we need to do. So that's good. It's not full context. you can pull all kinds of things into your IDE, like requirements and stuff like that. And all these will probably create better results for you. This is like a probabilistic world. We don't know what will happen. The only way we can actually maintain control is, like I said, review everything, approve everything, and we need to do that. Okay, so what did I do? Well, this was kind of a cool thing for me because when I was in high school and I was programming in Prolog, one of the exercises that we did was the Towers of Hanoi, not these ones, not the one you see on the screen. So the Towers of Hanoi are it's like a puzzle or sort of an exercise in algorithms that you have to move. Show you. It's this. You have towers and disks on it, and you have to move everything here up to the other side, and the only rule is that you can't put a wider disk on top of a smaller disk, so you have to move them like this, and then you have to move this and put the smaller one on the top one, and it's a nice thing. And I chose this because I had this kind of idea of what I'm going to show you. It didn't pan out exactly as I wanted, but that's okay. What else can I tell you about this? I'm going to go through the steps. I generated this. So at the beginning, I generated this through AI with Mr. Claude, and I'll tell you what exactly happening here. I want a couple of things that you need to remember as we're going and moving towards things here. This is a React component. It also includes this part, which tells you the temperature in Hanoi right now. It's not 28 degrees Celsius right now, but it is. So there's a part of the component here is calling an API to some kind of service, which will try to mock in different ways. So that's one thing. The other part is like this configuration thing, which is another component. And this is part of the page. This actually runs, like, can actually start, like, this is cool. It actually solves it. And the reason I think like it worked out of the box, which it did, is because this is like a known algorithm. So it's easy to find something on the network that some kind of solution for that. One thing that I did ask, which will go into our purpose today, is the separation between the logic of this thing and the UI. So I have a React component that shows you all this, but the logic of the algorithm is another class. I wanted this because first, if I would generate code for that, this is how I would ask it to do. But also, I know it makes easier to test and to show things. Okay, so this actually runs my machine. I'm going to start with what I asked. So don't need to split. Okay, we'll work with text. So first of all, about generating the code, what did I ask? So this is going to be in TypeScript. The reason, because of the component test. But most of the stuff that we're going to talk about today apply everywhere. So create code in TypeScript, a React component shows the towers of Hanoi simulation. 3 towers, left tower is full with 5 levels. I didn't know it was called disks by then. Okay, it kind of it knew. The component should have a reset button, should have a start stop button, and separate the logic into a separate class. Class should have a next step. This is where I actually imagined how these things will actually work. I'll show you my surprise in a second. Component should also have a title of Tower of Hanoi. It was in the beginning part of component, then I moved to the page. Next, it shows current temperature in Hanoi and get it from a free weather API. Like I said, it's not live. The code is there to fetch it live. I didn't provide it with an API key because I wanted to show you tests. So this was like worked out of the box, really. I really was surprised that it actually worked. Then I asked it to modify the code to have between 3 to 5 towers. So I can actually change that. So it created the control, the configuration control for me. Didn't ask for it, but it did. So these are passed as props to the UI, 3 to 5 and 3 to 6 disks. And finally, I asked it to write another code that sets the tower and this that sits the page. Oh, this is the control, really. So this was just changing the interface of the component. Sit on top of the tower component, there will be a set button. So yeah, it kind of create like over bloated configuration thing with previews and stuff like that. Yeah, it did what it did. So I was kind of surprised. So let's look at the code. So this is the logic part. You can see that there's a constructor with the default parameters, makes sense, a reset button, exactly as I asked. It created a method called generate moves, a private method, which calls itself through recursion. So that's one of the main characteristics of the algorithm is that it is very takes advantage of very much takes advantage of a recursion. Now, I thought the next state, which I asked for, would actually be the one that generate states did, because I thought I'm going to ask the next step, test generation. But what actually happened is that it kind of works off the generated test. So when you actually press start, it actually generates a whole tree of moves, and then next step just goes through that, not tree at least. Okay, other than that, he has a couple of getters here, not very interesting. A bunch of data objects that I put here, and now the configuration. I want the tower component, which is the React component. Bunch of red squiggly lines. It doesn't really matter because it works. You'll see that the props are passed in, default 3 and 5. So I can select how many disks and towers are there. The use effect, if you don't know React, this is where we actually do some kind of async calls, including our fetch weather, which is important for us. So you'll see that the fetch weather thing actually fetches does the API call, but also for our case, it actually rounds up the result. So this will go into effect when we talk about our tests. And otherwise, it shows the 28, which you've already seen, and a bunch of animation, start, stop, and a bunch of React. This is a lot of code. This is something that probably will take me to hand code. I reckon between like at least 1 day or 2 days, like to make sure that it actually works. This worked out of the box. We're talking about 10, 15 minutes. So really cool. But we want to talk about tests, not about just generation. So the first thing I asked is, like I always do, and this is something that you can do like every time, for the Tower of Hanoi logic, the entire module, create test case suggestions, don't implement yet because didn't want to move too quickly. So it created per method, constructor initialization, reset method, move generation, next step method, and the getters. So a bunch of these things, and remember, it has context. It knows the code. It can actually read the code, sort of understand it, which is good. And because we're running in an sort of an open environment where this is like a known algorithm, it probably brings its context along with it. But like most code generators or test generators, it starts with the code itself, and you can see it here. I could have asked it like to go in different way, like different workflow and so on, but most people and most examples out there start from the code structure, and you could see that here. Note that move generation, this is like the next, not the next step method, but generating the moves, has a couple of three things. Should generate the correct sequence for moves for 3 towers and 3 disks. The classic solution should generate a valid move sequence for more than 3 towers, auxiliary towers, efficiency. Okay. This is something that in the unit test world, probably I'll be going a lot more deeper. And the reason is that, yes, it's interesting to see that it actually works in different scenarios, but because we're talking about recursion is something that's very complex. Let me just take you back to this pieces of code here. Just this like very nice short method, but it's like 3D method. If you actually want to test that, it didn't, because it put it as a private method, and it's being called from, I think, the reset. So whenever you do a reset, it recalculates everything. But how does it calculate, which is kind of what we're interested in unit tests? This kind of thing, a lot of ideas like are not there. So lesson number 1, always review the suggestions, and you should also have your own judgment whether like this is something that is may seem like it's like, I don't know, 20 lines of code, which is probably not a lot in today's world and different languages. But yeah, this is a lot of cases in it. It didn't do what I wanted it to do or what I intended it to. Okay, next thing I did, and this is something that I really I suggest and recommend to people to do, not just with AI, is this: generate empty tests for each case you've created, generate from the markdown empty vtest test. So I was test here are with vtest. I found that I need to tell it which thing, otherwise it goes to its default. Here it was just stuff like that. So I created all this thing, and it's kind of the same thing, really, only marked down differently. And then it created this for me, like scribe and thing. Now, why is that something that I really recommend? If you go test by test, you can't really see for yourself unless you're finished. What does this do? What does that do? And if this one fails and if this one passes, do I have enough differentiation to see what the difference? Also, so this is very helpful. Also from that, you'll see that this is something that a lot of people will write test names like that, which is sort of like should initialize default disks and towers. Yes, in what context? Or should reset to default state. Okay, what is the default state? Here you have should clamp number of disks to minimum, which is 3, which is better. You'll see that at the end that I'm kind of going to refactor that. I usually like recommending when then. But this is like an overview of things inside the code that you can actually look at and see, okay, I'm going to go through these are not important, and so on. But the boilerplate, like, go through it. Why type everything? So that was nice. Next, I also asked for the tower component to create a list of test cases. That's the React component. Don't generate code. It's very important if you want to move slowly. So it created this. So this is a bit different because it's a component, but you can start seeing the difference. So first of all, initialization and rendering. So taking the props into account, what it looks like. Something I really recommend doing as part of component tests. The game control, the start, stop, reset. This is really the functional stuff, which is interesting. And spoiler alert, will not work. The logic and state, the weather integration, which is nice because, again, it goes into the code. It knows where it's going. One thing I didn't tell you, I created the component, all the code outside the IDE with Claude. And everything else I worked with GitHub Copilot, with ChatGPT, I think, OpenAI. So the generation of the original code and what happens inside the IDE are disconnected. So everything basically what my ChatGPT partner here actually knows is from the code and what it knows from the code and asks the internet about. So again, if you're working on something that's similar to something that people are working on, you'll get good suggestions. Otherwise, less so. Also interesting, the accessibility and responsiveness things. Accessibility is something that is becoming very important. Should have accessible button labels and roles. Yeah, okay. Again, not the cases that I would choose. Should render correctly on different screen sizes? Probably. Yeah, I would do that. And is that a unit test, a component test? It should be on more like a page test or something like that, like Selenium or Playwright. Don't know. But we're in the ideation phase, so like we can actually make judgment whether we're going to do this like at the unit level or outside. Edge cases, I don't like edge cases. If you've seen my video about why I don't like edge cases, you know why. But let's look at the suggestions. Should handle rapid clicking or start, stop, reset without crashing. So this is actually one of the things that I actually suggest when we're doing like test planning exercises, like what happens if somebody presses this button like this. So this is interesting. And usually when we're thinking about these things, about bigger frequency, bigger speed, stuff like that, you're kind of thinking about, well, do we have code for that? So this is like a good case to suggest. Prop changes during an active game, good. Again, I need to know the application in order to say, okay, the component itself can do stuff, but what happens if it's during the animation? Should not mutate internal state when props change. Well, if you go into unit testing theory, maybe internal state mutation is something that is allowed. The effect of that may not be allowed. So this is like nice, and you can within each category you can ask more things, and you can get more ideas, and this is kind of cool. So if you're new to unit testing, if you don't know where to start with, like this is like a good start. Talking about not just the completion of tests, but also the flow. This is pretty quick. Okay, so these were the ideas. Let's get down to business. So next thing I was said, well, generate the test for the get current state. This get current state, let me remind you, this is kind of a not like this is like Okay, it's mapping the towers to something. And so I wanted to see how it's handling that. Generate tests for the current get current state, but in a separate file. This is something that I learned I needed to tell it because it would by default where the cursor was, and kind of need to undo and retry, and it breaks the flow. So do that. You get a couple of things. This is like not very interesting method, and you can see that it does test the get current state, but it creates it and it creates the logic, calls it, does the expect. Checks the as is animating stuff because the is animating flag is in this code. Is this important for what I want? Probably not. I need again to see if I would leave this thing here, because otherwise this will fail the test. Is that important for me? Probably not. The other thing is that it actually called the constructor, then called next step and next step, which is like a unit test, because we have a unit, but it's like not testing the method, testing the method as part of a sequence, which is a unit test. It's okay. But putting it under the get current state thing, probably something that I wouldn't do. Did not mutate internal towers array. Okay, it pushes 99. This is like a JavaScript thing. You can access the private members and can change them. And you can check that it doesn't contain 99, which is okay, not something that I would probably write at the beginning. So what does it mean? It means that, yes, you can generate, but the minute you do that, you can get into a sequence of, let's review everything. Also the code, what it generated. Does it match what I wanted to test? Do I want to leave it? Does it test extra? So on. Remember, it really ties into the code, which is a good thing and a bad thing. Okay, I did that. And I said, okay, let's implement in separate file two tests following these two cases. So these two cases are for the component test. Should render the correct number of 1,000 disks based on props. Now we do a reset or something like that. Should update the UI after each move, disk move between towers. So this is like taken from the list it suggested. So this prompted a list of things that I needed to do. First, move from jest to vtest, then kind of created code that doesn't build, so I need to put an import there. Again, not big things, but something that not always it will create things that you expect, which is weird. Like it should know that I have vtest here, and that the context that we're talking about is in the project, but it doesn't always work. A document is not defined. Again, creating something about documents. So this is about JS DOM and to make all kinds of things. The way components testing works is that I'm using React testing library here. It loads the DOM, kind of think about a mini browser. It's not a mini browser really, but a DOM container that it can actually query and manipulate. So the code it creates has kind of dependencies that it asks for. I needed to do that. I needed to configure Vita to just DOM. I tried doing stuff with it, didn't work. So some of the things are easier to do manually. And then at the end, what I had is a couple of tests, and one of them is passing. This is the should render the correct number of towers in this based on props. So gives it a 4 and a 5. And I want you to look at this. This is passing, which we'll look into detail in a second. This one sort of mocks the animation and creates some kind of time advance to check that. As you can see, when it created something, it created with a 10 seconds timeout. It raised it to 15 because it didn't work out, and then I raised it to 40,000, which means 40 seconds. It didn't work, and it won't work until the end. Again, this is something that I didn't go into, but doesn't always work. So you need to run the tests. This is interesting. So how does it know that it painted the component correctly? So a bit of React testing library here. It checks for the text tower with a number. This thing, tower 1, tower 2, tower 3. And it checks that the tower labels are, there's 4 of them. And the same thing with the disk elements. So this looks for the number 1 to 5, and then it checks that the disk elements are 5. So it doesn't actually check that it was drawn. It checks for tower 1, tower 2, tower 3, and 1, 2, 3, 4, 5. again, in the context. Is that exactly how I would do it? Probably not. Okay, so even the generated test that you ask for and you get, and this is not like it didn't understood the assignment. It kind of chose to do it differently. And if we're talking about confidence, we're talking about, is it checking correctly? The answer is no. Okay, next. I asked it to create more tests. So create 3 more tests to check the component rendering based on different set of props, include out of bounds options. It actually created, I think, 4 or 5. So this is the original one with 4 and 5, and you have 1 and 1, and you have 10 and 10, which is the maximum, and 0 and 0, which is not allowed, I think, and -2 and -3, and -3 and 3. So it's like asking someone to talk about what are your edge cases, and he looks at the edges and says, I'll try different numbers, which is okay. But it was okay for this one, didn't work. You can see that a couple of others. So the cases are okay, but I think that the starting point of what we have is not good because it continues to check the same way that it checks. It's not the right way to do it. Plus, I have more non-passing tests, which is not good. Okay, so lesson of the day for this chapter, you can generate, but you can have to see what was generated, if it fits what you actually want to test, and if you need to run it to see if it actually works, because it doesn't. If you have like something like windsurf or cursor, stuff like that, you can tell it the rules are like do things until things are passing. You can iterate to that. One thing I showed in my web testing webinar when I generated tests is that it kind of modified a working test or modified part of a working test without me knowing, and I noticed that like only when I looked. So yes, there's a chance that it will change things that are already working or pieces of code or pieces of tests. You need to be aware. Again, this is a flow impediment. I asked it a couple more questions because I thought about the responsiveness and stuff like that. Generate responsive tests for the component in a new test file. So it created. Should render correctly on a large screen. So it gives like a bigger window here. See, like, things are sometimes passing. I'm not sure why it's not. I think it passed before. It checks that it has a class. Yeah, so this is like trying to use the wrong tool for the job. So yes, you can set a viewport, but what you're really interested is, are you seeing things inside or outside the viewport, not if it has a class. So again, yes, it worked. I think it worked before. I don't know why it's not working now. It generated a couple of things, but you need to work with it to see if it actually checks what you actually want. Even if it were, you ask, does it work overflow? It checks that the text of the Tower of Hanoi, remember that's the top there, has some kind of non-scrolling thing. It's possible to write it in a different way. Again, you have to know React. Need to know about React testing, and you need to know about how you do these things, how you check, which is like more than in the unit testing. How do you check correctly? This doesn't go away. Again, I know that models today will be better tomorrow, and tools will be better tomorrow. But if you want to trust your tests, you need to review everything. Right. Second thing I asked for is accessibility test, and I was hoping or expecting something, which I got, but in a different way. So I said generate accessibility test for component in new test file. So usually if you want to test accessibility, there's a library called Xcore, AXE, which does this for you. It doesn't do everything, but a lot of automated things you can do. And I was expecting it to do this for me. Actually, it went a bit creative. So it created accessibility, like should have a main heading with appropriate role and text. So this checks like if something has the right role, accessibility role. Again, this is a bit more front-end things, and it checks that it has the roles. Would you check that? And you see that things are, is there a start button in the document? And you can find it by checking it with the role. So it is basically it is an accessibility test. Is this something that most people will write? Probably not. What they will ask is for this. And this is created in a comment, which I uncommented, but this specifically is the use of using the X library. You can render the component, give it to the X thing, and ask it to have no violations. If it has, it will get like a list of all the things that are wrong, like in terms of contrast or font size or stuff like that. This is what I was after. It gave me that, but not like, this is where it actually chose to say, if you have the Xcore library in your project, which it can know, you can use that. And this is how you should probably operate. Again, these are the things that are, we talked about responsiveness, about accessibility. We can do a lot more. And we can do better, and we can probably like squeeze it out of the genie, but I didn't. Okay, next was investigate the code. This is something that you can do because you're inside the IDE. And I asked it to explain how the algorithm works. What are the edge cases? It's not unit testing, but if you understand how things are supposed to work, then you can write tests for it. Not exactly the answer that I get. So what happens is that it actually explains it in a way that, again, I didn't expect, which is this is the code and this is how it implements the puzzle. It's not how I was thinking, well, how does the algorithm supposed to work in order so I can test it? Not exactly. So it gave a good explanation. It gives me idea of the edge cases, again, looking at the constants and the clamping and stuff like that. So yeah, it's nice. So you can actually ask, as long as you're in the understanding what your problem space, you can ask it, what does it do? What are the edge cases? Like, give me ideas of where to start. And this is like a good idea. Second thing I asked it, like, are there any possible concurrency issues in the logic? What kind of test cases should I use? Check. And this is a JavaScript. This is React. It works on the main thread. So it actually knew that. So there are no explicit concurrency issues in the current class. The class is designed for single-threaded synchronous use. However, if you use this logic in in multi-threaded or asynchronous context, you could encounter issues such, and this is like an interesting cases which you can actually dive into. So I remember I asked for the logic to be separated from the component, but knows that it is only used by the component. Therefore, it sort of deduces that it's not going to be used in a way which is like multi-threaded scenario, but it does tell me things like that. So this is a good idea, like code that is new to you, code that you're not sure about it. You can ask questions about multi-threaded things, and it takes into account that this is written in JavaScript, and therefore this is the way it's supposed to work, and the probability of things that will happen. It also knows that this is a logic thing and can be used somewhere else, and therefore it gives you the ideas of what to check for other cases. This is sometimes not visible from the code. Like most of the time, it's not visible. So race conditions, stuff like that. If you're not aware that things might happen, you might not even think about asking a question. But you can do that. And you can have some functionality in edge cases and so on. You can look at this and say, these are good ideas. How do I actually how do I design a test that actually do that? Like, this is like a bit different than regular functional stuff. And it actually tells you if you want to test for concurrency, you would need to simulate or mock concurrent calls. This is not typical for this logic in React app. Yes, this is like a good suggestion. So again, you need to know, to be familiar with the technology, the usage, and so on. So you can make better decisions. Let's talk about mocking. So I tried two things. First of all, I asked it to generate a mock for the API call. So the tower component issues the API call. Remember, it goes to the weather, open weather server, and gets an API. Generated test in a new file that mocks the call and return 25.2. It should be rounded to 25 and checks that the right temperature is displayed. Didn't tell it, but it knew. So it actually did that. It's using vtest mocking to using VIFN, which is, if you know jest, completely the same. And it's mocking at the function level. So when the function, the fetch is called, it returns 25.2, and it actually checks that 25 degrees Celsius is presented. It's exactly what I wanted. I actually wanted to be visible, but to be in the document is good as well. So this can see it actually worked. And then I tried something else. So this is mocking the function level, and it doesn't really issue a request outside. What if I actually want to do this? So there's something called a mock server worker. So a mock server worker generates a worker thread with a server on it that can that the request is issued to that thread instead of the real server. So it's mocking, but on other threads, and this one actually invokes the issuing the request. So I asked it to generate a test. A new file mocks the call, return 25.2 degrees. So this is same value, and checks that the right temperature is displayed. Don't use vtest mock, use mock server worker instead. And did that out of the box. So it looks the same, but the setup is different. So it actually creates a server that listens to a GET request to API to openweb.org. So it kind of raises it before the test. And then if it got a GET with this URL, it returns this JSON and this status. And I'm actually checking, more like a mini integration test, that the request is actually issued. I can check what was sent there if I want, and I'm mocking the response, and other than that, same thing. So it's a bit more than a unit test, but you can see that it can generate these things, and sometimes it's easy, sometimes like there's bit code involved, so you can use that. So that was mocking. Final part of things that I want to talk about unit testing is refactoring, because that's the trifecta of unit testing. The tests, the mocking, and the refactoring. So I asked it to create. This time I wanted a different copy because I wanted to keep the original here. Obviously, if I was refactoring, I would refactor in place, but this is a webinar, so I decide what to do. Create a copy of the logic class, name file class refactored, and refactor the new class to make it more readable. So no direction yet. The original code was not that bad, by the way. This is like a bit shorter, less verbose. It did something with the loops here, which I'm not sure I like, but okay. It's a bit more, it's shorter, a bit more readable, so I didn't complain too much. I asked it to refactor the tests for me, so refactor the component tests in a new file. So remember, we have the component test, the one that checked the props, and the animation that doesn't work. So basically what I asked it, I did. Yeah. Pull common code into fixture methods. I thought it would pull the code into before each and before stuff like that. It didn't. It kind of create a fixture by definition, which is like common methods, which it calls from the test. Not what I asked. I'm sure that if I asked, it will create what I wanted. I did ask though, and this is something that you might like, depending on how you like to read your tests or write them. Refactor the component test to have when-then naming conventions. So remember, we had like should this and should this and should this, but I like when-then. So now I have when given 4005 disk, then renders 4005 disk. When given minimum values, then renders 1000. I like it better. Again, this is something that you can fight over with your teammates and over what is the way to write test names. But remember, you can do this as well because it has the context, it has the code, it has the way to create legible names. And remember, if you're using like in JavaScript, you can put like full sentences, and you have other ways to do this in other languages as well. But the option is there. Make tests even more readable. Final thing I want to show you is the magic stuff. So what is the magic stuff? So all these things I told you what you can do, and you need to validate everything, and you would probably want to go very slowly, very small steps in order to do this validation. But AI can do magic, so let's do magic. So refactoring is very consistent. You do small refactorings, you do renaming, you trust it works. But what happens if you ask it that after you copied it, refactor the new class to replace the recursion with loops? So this is like completely, I wouldn't even say translating, I wouldn't say refactoring, it's replacing or rewriting the algorithm. So instead of recursion, I asked for loops. So it actually did that. Well, it did that. That's not a real magic. I expected it to do it. And you can see that there's a whole new implementation here using stacks and stuff like that. Again, I didn't say what kind of, I just say loops. There are loops in there. But I also took the tests and checked that they worked. Is this refactoring? These are the get current state tests, remember? So this hasn't changed much, obviously, and they still working. Has the algorithm been refactored completely? I don't have tests about all the mini things that happens between different steps, so I can't really be sure. But these tests work, so yeah, ship it. So that's magic number one. Next one is I wanted it to fix the test. So you saw that some of the tests weren't fixed, fix them. And you see that, yeah, it fixed them. How did it fix them? I need to go in and look at what they have and so on. You see that it's the it's something it had to do with query because things were not there. So again, this is like React testing. If you want to see something that's not there, you have to query it. Like it worked. So some of the tests did work. Animation test did not, so it was not fixed. Whatever I fed it, it didn't work. I need to actually go in and do that. Finally, thing that I asked but didn't get much, but it's something that you can do as well. Is there a way to optimize the test for performance? So this is like something that is interesting because I didn't ask the code to be more performant, which I could, but specifically component tests are slower than real unit tests, and I want to make sure that I can optimize them for something. So what it didn't do what I wanted. It told me that it added this actually. So after each, it kind of unloads the DOM, but it also told me that this is handled automatically by the testing library since version 14. So not much here, but you can like drill down for if you want to run things on multiple threads. What does it mean? Can you optimize stuff and stuff like that? So you can ask it. I'm guessing you will get some kind. It understand the concept as you can see, and maybe you can get some ideas out of that. So that's cool. That's what the old examples that I have. So what have I learned? So first of all, we need to align our thinking about what we want from the test. We don't want to generate tests. This is easy, but we want to generate tests that we will feel confident about changing the code, about knowing what's happening there. And that requires a lot of things from us. Again, not new. We need to be the chaperones, the guards, the approvers and confirmers of things. We need to understand how the code is working. We need to understand how the tests are working because we need to understand what they're doing. Otherwise, we can really tell it doesn't do the right check that I want to do. You need to move in small portions. This is like so crucial because everyone who's worked with AI and tried to generate a bit of code, it wasn't a bit of code. So in order to like keep track of everything, you need to do things in small portions and review them because otherwise you like work for 15 minutes for generating stuff and half a day for reviewing everything, which you won't do because like we're human. We're not, maybe AI can work or review a million files of code. We can't do that, or we can't do this effectively. And again, what we're trying to do is get the confidence that our code is working and the tests are okay. If we want, we kind of let it loose. We'll pay for that later. In our case, for example, I had either tests that are not working or tests that check the wrong thing and when they pass, if I don't understand what they're doing, will give me the false confidence that the application is actually working. So you always need to always need to review what it's done to you. Small steps, very small steps, very small commits, because otherwise it gets out of control very quickly. But the good thing is that if you know what you're doing, if you know things are working, you can ask it to do stuff and not just count of it to do the right thing. You can validate it and wind up with tests that you want, which is what we want. A couple of warning shots. If you haven't done unit testing before, I think the worst thing that you can do is to start generating tests because of everything I told you. Yes, it will generate tests for you, but if you don't understand what it does, what it checks, what tests are, what you're actually testing, how things are working in order for them to test, what you need to set up in order to test correctly, all these things are probably will give you false confidence. So I really recommend like spending some time, days, weeks, writing tests by yourselves. Otherwise, you won't understand all the things about testing. If you don't do that and you kind of delegate it to somebody else, somebody who's always right, if you recall, is never wrong, you're going to be surprised at the end. Another problem with just generating tests is that if you have bugs in the code, the AI will not know that. This is like an application bug, not a code bug, something semantic. It will just generate tests for the code. It may say, oh, this is interesting, but it may also think that, hey, this is the way the user wants it. So generating tests for bugs in the code means that you'll think that this thing is working while it's not. Again, surprises, we don't like them. Also, a thing about problem with generating is that unit tests, as usually what they do is kind of lock the code in place. It calls a function, so it passes the functions with the right parameters and so on, or it mocks the thing that it needs to do because this is the signature right now. When we're talking about the pain in test maintenance is that we change the code, we need to change the tests. Now, if this happens a lot and you have like a lot of tests because you've generated a lot of tests, either you will feel the pain or you just drop it and you say, well, we generate everything, which is kind of get us to square one. We have tests that gives us false confidence. We're not sure what they're doing. So this is something why you need to work in small steps. Again, you can validate, you can understand what's going on, and you can improve. So yeah, you don't have to practice unit testing 3 to 6 months before you start generating tests. I know you won't, but I really recommend practicing with, at least if you want to start tomorrow, look for ideas, look for empty test cases that you can fill in. Before you write any code, just the test case names, go over them, make sure you understand how things are, what you're going after, and then you can maybe generate something like that, see if it actually does what you want. But the more experience you have, like with manual tests, you will get better tests, better testing experience. When you're going to refactor code or rewrite it or something like that, do not assume that it is actual refactoring. Apart from things that I didn't do today, like I changed algorithm from recursion to using a stack based, same with the loop, didn't check anything about the performance of that. So even usually with unit tests, we're thinking about the functional stuff. Does it actually work? Yes, but does it work in a sort of quick way? If I refactor the algorithm, does it meet the benchmark that I had before? So on. So if you refactor, make sure you have tests that you trust and all tests that you trust. And I really suggest like working with AI with smaller functional unit test and moving on to component tests. You need, it's not like the test framework is different, but the scope gets bigger and you can move forward with integrated tests a bit more like that, like I showed you with the worker server and stuff like that. And it's like maybe crawling out of unit testing world to the world adjacent to that, to integration world. And that's okay because you're writing the test that you actually need and want. Final thing I want to say, to be very short, about where we're going. And this, I'm going to dedicate a whole webinar for that. So stay tuned. So I'm going to throw a bit of a bombshell here. I think that unit testing are not in the future. It is in the short-term future. But the more we generate code and regenerate code, I think we'll work with less code and therefore we'll have less unit tests. I'm going to dive deeper into that and the whole like the future thing about AI, but that's a teaser for something that's going on. And that's what I want to share with you today. So that took a lot of time. I hope you had what you found valuable. As always, you can check out the website, ping me, ask me questions. Thanks for coming. We'll see you next time. Bye-bye.